Going live. Okay. So let's just do number one. It says find the equation of the line tangent to the graph of y equals x squared minus 1 at the point 2, 3. So first you got to parse the sentence. So it's saying there's a curve out there. The curve is y equals x squared minus 1. We don't know what that looks like. Okay. It's saying that this curve has a tangent line, and it's tangent to the graph at the point. Let me make my graph a little bigger, maybe. So this is the point when x is 2, y is 3. Not my best drawing of a graph, but it's good enough, I guess. So yeah. But so everyone understands that, right? This curve has the point 2, 3 on it, right? So if you plug in 2 for x, you get y equals 3. And there's a tangent line to the curve. So I could draw this line that's tangent to the curve. Now, a lot of times, for artistic reasons, God, that's terrible. Sorry. For artistic reasons, you might draw it a little bit less to scale just to emphasize that the tangent line just nicks the parabola at one point, okay? So we all feel comfortable with what tangent line means?
Yes.
Okay.
Yes.
So this line has a formula that describes the line, right? The question is asking us to find the equation of that line. So to find the equation of a line, you need two things. Who knows the answer to this?
Slope.
You need a slope. That would work. So if you had the slope and the y-intercept, you could use slope-intercept form. You could also do the slope and any point on the curve. When you learn in calculus, point slope form is your friend because it's this one. Could we, in theory, somehow find out? I mean, the y-intercept would obviously be some like negative number, right? But we don't need to find it because we can use point slope form. So we're going to be using point slope form a lot here. I'll give you a quick reminder. Point slope form says that if you know the slope of your line, call that m, and you know a point on your curve, namely x1, y1, then your line has the equation y minus y1 equals the slope times x minus x1. So if you Google point slope form, that's what you see, or something like that. Okay, so what's my point on my line? What point do I know lives on my line? The point 2, 3. Great, I'm halfway there. How will I find the slope? Take the derivative. So my derivative would be, so this for this parabola, y prime would be 2x minus nothing. So the derivative evaluated at the point 2, 3, that like bar means evaluated at. Which number do I plug in? The 2, not the 3, because the 3 is a y value. So you plug in 2 here, so 2 times 2. There's the slope, Okay.
Yay.
So my answer then to the question is y minus 3 equals the slope times x minus 2. Oh, lovely. We're done. See how easy that was? Painless. For those of you, I know you guys are very curious to know, what was the y-intercept? If we did extend this line all the way down, it turns out it would just be, what, negative 8 plus 3, negative 5. So my drawing maybe wasn't super duper to scale, but wrecked. All right, we feel okay about that?
Yes.
So let's cover two things at once. That covers the main idea, but tomorrow we'll have some kind of mixed work time. Slash we'll be going over some questions, but the first. So I guess class is so full now. I guess we're just missing what, Ray, Kate, Alyssa.
I think she slept in apparently.
What a savage. But anyway, for those guys, if you're watching in Griffin, I'm going to cover the other thing, which is this is actually a big thing in computing because it helps you approximate things. I'm going to show you exactly what I mean. So don't worry, you don't have to do all of 2 through 14 for homework. We'll have some time in class tomorrow. But I'm going to show you for number 15, how do you use this idea to approximate a value? Okay. So this says, given a function given this function, approximate what would f of 2.1 be? So these kind of questions always raise a very valid question. Like, can't you just literally plug 2.1 in and just do the math? Yeah. Yeah. But that's not the idea we're getting at is obviously keep in mind, we're doing simplified versions of a larger idea, and the larger idea being certain like very complicated functions. How does a computer know, for example, that the sine of 28 degrees is 0.469471568? Like, how does it know? How do they figure those numbers out? And this kind of gets into one of the ideas of how they can do that by taking the function and breaking it down into its derivatives and making approximations. So anyway, let's get into it. Okay. So the idea here is this function. Do we know what this looks like?
Yes.
It's a parabola, and it crosses the x-axis at what two numbers?
0 and -3.
Yeah, sometimes it helps to write it like this. So if you can do that in your head, awesome. If not, that's what paper's for. You can take that and say, okay, that can be written like that. So I know it's a parabola that crosses the x-axis at 0 and -3. So 1, 2, 3. So it's some kind of parabola shape. Now the idea is way over here. I did a terrible drawing again. Let me draw a little bit better.
Yeah, my drawing started off good and then failed.
So over here at 2, we could, and I need your guys' help because this might confuse you. Do you guys see how if I were to plug in 2.1 into my parabola function, it would give me a very close number to what if I plugged in 2.1 into the line equation?
Yeah.
Does that idea make sense?
Yeah. Mm-hmm.
Like, look how close the line is to the parabola. They're very close to each other. So what I can do is I can say in this neighborhood, this is my neighborhood, I can say that the line is approximately the same as the parabola. I can show you, this is a good one for Desmos. I can show you this real quick. Here, so if I graph y equals x squared plus 3x, and then I know the derivative is, let's see, when x is 2, you get what? 10. So y minus 10 equals 4 times x. No. Where did I mess up?
X plus 3, and then you plug in.
Mess up something simple. Oh, it's 2x plus 3. Sorry, that's 7. Okay, look at that. And we graph the point 210. Okay, in the neighborhood of this point, look at that. They're pretty dang close, right?
Yeah.
So this is the core idea here, right? Because if you're confused here, we can maybe answer some questions or. Yes, feel like you understand that?
Yeah.
Okay, so, all right, I'll believe you. So in the neighborhood of 2, the line, the tangent line, and the function are very, very close to each other, okay?
Mhm.
So what's the equation of that line? Okay, same procedure as we just talked about. So you'd say, okay, well, f prime of x is 2x plus 3. So what x value do you think I'm about to plug in? 2. So f prime of 2 would be 4 plus 3 is 7. Okay, so the slope of this line is 7. That's the slope. So what's my line equation? My line equation would be, oh, and what's the y value? You got to plug 2 into the function to get the y value, right?
Mhm.
4 plus 6 makes 10. You guys still with me?
Mhm.
So the equation of this line here is y minus 10 equals 7 times x minus 2.
Mhm.
Everyone okay with that still?
Mhm.
Because 2, good question, 2 is an awfully close integer to 2.1. So we're always going to pick the integer we like working with integers, right? So we're going to always pick the integer that's closest to the number we're trying to approximate, or the x value we're trying to approximate. Okay, so this is the equation of my line. Actually, let me rewrite it as y equals 7 times x minus 2 plus 10. Add a 10. All right, let's see if anyone knows the answer to this. What's the last step to this problem?
Switch the equal sign to a square root equal sign.
Very close. That's involved. It's involved.
You solve the
Solve for x
2.
and make.
Solve the
Plug in 2.
Close. We're going to plug in 2.1.
Oh, you actually, okay.
Because now think about this. This line, remember, this line is awfully close to this parabola in the neighborhood of 2. So if I plug in 2.1 into this line equation, let's do that. Plug in 2.1. 7 times. So what's 2.1 minus 2? 0.1 times 7. 0.7. 0.7 plus 10 is 10.7. So now the answer to my question is that come back up and say, well, okay, I guess that f of 2.1 is approximately 10.7. And the idea is like, okay, what is going on here? Well, for a computer, subtracting 2.1 and 2 and then multiplying by 7 and adding 10 is going to be a lot easier, less expensive for the computer than, say, squaring a number maybe. Again, this is a very simplified example. So the purpose of this would be a lot of times to like make a computation more efficient so that computer can perform more calculations. Anyway, so does that let's see how good that approximation was. I can ask Mr. Calculator what happens if I literally just plug 2.1 in? Let's see how good the approximation was. 2.1 squared plus 3 times 2.1 is 10.71. So our linear approximation was off by 100, which is pretty good, given the size of the So anyway, so when we take a quiz on this, it's just going to ask you, what is the best linear approximation you can get for this, given this function? And this would be your answer, 10.7. Okay? Lit.
Lit. Very lit.